Welcome everyone. From my side, my name is Tobias Pflock from NETZSCH Analyzing and Testing. And you signed up for today's webinar on failure analysis of injection molded parts. Co-hosting Mr. Martin Doth from Kunststoffinstitut Lüdenscheid in Lüdenscheid, as you might have guessed, in Germany. So welcome, Martin, for you.
Hello. Welcome from my side too. I guess we have some time.
Yeah, we still have some time.
We start. Yeah.
I think it's should be quite early in the US. I assume there are some people from the US listening to us. Just what we do at the beginning, as this is a live webinar, and Martin and I are live in front of our computer screens and talking to you via the voice transmission. Can we get a feedback from you if you are able to hear us? And you should see kind of my PowerPoint setup, or including the first slide. I start that. In order to get into contact with us, please use the chat function of the webinar toolbar on the right. You should see this toolbar, and you could just. I see some people are. Tell me more. Yes, someone can hear me. That's very good. That's very good. Okay, so we have quite an international crowd again. I assume you have people from the US. This morning for you should be about in the morning, but there is still people in. Well, some people from Poland, is that right? We have Italy. I have Italian names, so maybe you can give me a short feedback on where you join us from this morning or this afternoon for the webinar. I see more people are coming in. Don't worry, we start in time. And if you could give me a short feedback where you're coming from, where you're joining us from this morning. Oh, Canada, yeah. Oh, Canada, our home and native land. Okay, more people are coming in. I see that. So webinar is filling up. But don't worry, we will start in time. So there's still enough time for you to grab a coffee in the morning, or Canada, obviously, just about to go to lunch, or for us, Martin, here in Europe, well, later in the afternoon. Some people might still need a coffee, including myself. So, UK, we have someone from Manchester, UK. Welcome to the webinar. I said people from Italy. Welcome to you. So I guess you had a coffee already in Italy. Okay. I see someone that dialed in from Romania, if that is right. So welcome also to you. But yeah, let's say we just take some time and wait until a few minutes before, and we will start in time at this is 1700 Central European summertime. Believe it or not, it's still summertime, although I really don't know if I look outside. If you consider this summer. What about you, Martin?
No, not really summer.
Your summer activities in the rain? No.
We have always rain, so.
Okay. I thought UK is more rainy, but actually that's quite interesting. I once read that actually people think of London as a rainy city. Actually, Munich or Berlin are much more rainy than actually London. So you should spend your holiday in London for.
And Lüdenscheid is one of the rainiest cities in Germany.
Okay.
We have won that prize more than one time in the last years.
As I said, a listener just writes, it's sunny in Manchester, so that's good for you. Just as everyone deserves, I guess. No. Okay. Okay. But we see, like if I looked on the registrations for the webinar, we see quite um, quite a variety of people from different, let's say, different companies, different applications. I assume many of you have to do with injection molding themselves or with analysis. So that's kind of the how we came up with the idea of this webinar. And I assume, Martin, for you, injection molding is quite a common thing to look at. If I look at Kunststoffinstitut Lüdenscheid, how many machines do we actually have?
Injection molding machines. I'm not 100% sure. 7 or 8 from all main manufacturers.
Okay, so
with different techniques.
Yeah. So you get this quite often at hand to yeah, we produce this part, so Martin, please analyze it for us.
Yeah.
Yeah. Okay. We will go.
What I do.
We will go into that later. And you have extrusion lines as well
that's
right, for compounding.
At the moment, one extrusion line, maybe in a few months a second one.
Yeah.
Not for the production, but a compounder.
Yeah, that's right. Okay, so you do everything from I guess you will get into that later. Everything from material, let's say material research to process
failure analysis. Yeah.
Failure analysis. Yeah.
It's the other end. If there's something. Yeah.
But I assume you also do training on the machines, do you?
Yes, we do.
Okay.
In Lüdenscheid or at the customers all over the world.
Okay, that's interesting. Okay, I still see people are coming in.
Yeah. We have still a few minutes.
Yeah, that's fine. For the ones who didn't discover it yet and who recently joined us, welcome from my side. My name is Tobias Flock from NETZSCH Analyzing and Testing. If you want to get into contact with us, so you're here, we're talking here, we're just chit-chatting along here, but this is all live. And if you want to get into contact with us, please just use the chat function in the toolbar on the right side of your screen. And we will also have time for question and answer later. So yeah, a few more minutes. I don't know, I listen to Google time maybe. Let's see what cell phone tells me. Yeah, there's still 2 minutes to go and then we start.
Yeah.
But we're not in a rush, I think so.
No.
That's fine.
Enough time.
Everyone who joined right now, you should be able to hear my voice talking live here, and you should also be able to see the first slide of today's webinar on failure analysis of injection molded parts. If that's good, then then everything is working here. Okay, let's see. 1 more minute. Still people are waking up this morning, maybe from West Coast US. Good morning to you. For the other ones in Europe, I say good afternoon. Yeah, but that's quite interesting on these webinars. That is kind of a worldwide thing, really. And we save all the traveling on the planes. What do you think, Martin? It's not too bad.
No.
Yeah. Okay.
Saves much time for everyone.
And a lot, yes, and a lot of money.
Yeah.
Okay. I hope everyone got himself a nice seat or sitting in a conference room. Maybe have a coffee. I think we are about to start. It's about 5 a.m. here in Germany, and I would like to welcome everyone in the name of NETZSCH Analyzing and Testing. My name is Tobias Pflock, and I welcome you to today's webinar on failure analysis of injection molded parts. It's the third webinar in the series today, and a special welcome for my co-presenter, Mr. Martin Doth from Kunststoffinstitut Lüdenscheid, who will tell us about his experiences in failure analysis, and he will show us 3 stories of problems that kind of give you an idea how to approach such a failure analysis and give you a small overview of all the different methods that you do. Martin,
hello to everybody. Yeah, hello to everybody.
Okay, I would just go into business. Just so you have someone, well, you cannot see us, but you can hear us. I hope we speak clear. We did a sound check before. As I said, on the left side, that's actually me, Tobias Pflock. I'm a physicist, work for NETZSCH Gerätebau, which is the German subsidiary of NETZSCH Analyzing and Testing for 7 years, and I'm currently business field manager for polymer applications and for polymer questions, so it's a business development position. And as you might have guessed, injection molding is quite a huge part of polymer processing, so I'm concerned with that. And I'm very happy that we met Martin, I think it should be more than 2 years ago, at Kunststoffinstitut Lüdenscheid. Martin Doth has an engineer at the background, and I can just say that the Kunststoffinstitut Lüdenscheid is one of the #1 references for polymer testing and actually for the entire work show in polymer processing, from compounding to injection molding to analytics. It has 300 members. And of course, NETZSCH Analyzing and Testing is also part of this. Martin Doth is with Kunststoffinstitut Lüdenscheid for 6 years now, and he is the head of the analytical department for 2 years. So you've been dealing with a lot of failures already, and I'm really, really happy that you can share your experiences today. Just to put this in perspective, Kunststoffinstitut Lüdenscheid is a research institute for polymer. So Kunststoff is a German for polymers, and they have an accredited testing lab that Martin Doth is heading according to ISO 17025. I assume many of you are familiar with that, and they were just assigned as an A laboratory for quality testing of Daimler car manufacturers. So I think that's quite a nice reference to have. Third point I want to mention is the program of proficiency tests that they provide. We are participating ourselves with our equipment, especially with the DSC in it, and there's, I think, about 70 people were last year in the tests, Martin, I think. Mm-hmm. Yeah. And so that just gives you a very good reference if you're on very different methods, if your instrument is working right, and especially in the US, I know that there's people also participating. And so Kunststoffinstitut is a very good international reference for polymer materials. Just for the ones of you who are not familiar with NETZSCH, as you signed in already, you must have at least clicked on our homepage. The NETZSCH group has 3 different business units, grinding and dispersing in the middle with grinding machines for processing, pumps and systems to the right also for process applications, and the part where I'm speaking to you from is analyzing and testing to the left. We produce instruments for test material testing. Today we talk about polymer testing. There's also a wide variety of applications. If you're interested in the portfolio, just refer to the homepage, or you can ask me later about that as well. This slide is actually showing our new production site that you see here on the bottom of in this picture that we're actually just going to open it next week. So it's brand new, it's working already, and getting the instruments ready to be shipped to you. This is a slide showing the overview of all different methods and properties that we measure. I will not go through this in detail. There's a lot more detailed information on the homepage on the temperature ranges and application ranges and whatever. We will not spare time with this today. Just we picked out two methods that Martin is also going to talk about, and that is DSC, differential scanning calorimetry, probably the most widely used technique of thermal analysis, also used for failure analysis, and Martin will refer to TMA, thermomechanical analysis, to look at expansion and shrinkage of the parts as a function of temperature. Before we really start, a few more announcements. Maybe for some of you, it's not the first time that you join such a webinar with NETZSCH Analyzing and Testing. And I see there is an error that we will just change. Because the first webinar that is, the next webinar that is going to be about polymer analysis made simple, how state-of-the-art software Proteus from NETZSCH helps you to your daily work. So I think we could advance our software a little bit, and this will be on the 10th of October in 2 weeks. And then we will start in the fall with a complete series about composite manufacturing and how testing and analysis will be able to advance your composite production. And we will talk about all different methods. We will have a reference with Professor Drexler from Technical University in Munich as well, saying a few words about that. If you're interested in composite materials, or your colleagues are, you can sign up for these appointments via our website, and you will receive an email in time. 2 organizational points. If you want to get a hold of these slides, don't worry. We will send you a webcast of this webinar now. You'll receive this later with an emailing where you can also give us short feedback about how you like the webinar. And secondly, we will have a question and answer session afterwards. This is part of the format as we do the live webinars here at NETZSCH Analyzing and Testing. And if you want to get into contact with us, you can use the webinar toolbar that you see on the right, and there's you can just use the chat function and type in your question, and we will refer later, last time we did that during the talk already, so as Martin will present his example, you can type your question right away, and I will then pose these questions to Martin, and we can get, last time we got quite a lively discussion, Martin. What do you think? So yeah, I think if you just be active and ask your questions, and then we can really concentrate on the questions as well, because this is also what we are here for. Okay, rock and roll. Back to the webinar, failure analysis of injection molded parts from Martin Doth from Kunststoffinstitut Lüdenscheid, and I will just hand over the moderation. That's actually, we improved a lot, Martin. What do you think? So
yeah, it's
here we go.
Faster and faster.
Faster and faster. Okay.
And you should see my screen now.
Yeah, and I hand over to you.
Okay, thank you. I also welcome you for the webinar Failure Analysis of Injection Molded Parts. I will show you 3 different examples in the next 30 minutes, about 30 minutes I think I used the last times, and these examples will show you the possibilities of different methods to analyze plastic parts. It will show you that you often need more than one method to find the root cause completely. First, I will start with just 2 sheets about the Kunststoffinstitut. for you that you know who we are. We are providing support in all areas of plastic technology. That starts with the selection of the material, with development, but we also do optimization of products, of molds and processes. We are about 110 employees here in Lüdenscheid and 10 more in another in Villingen-Schwenningen, also in Germany. We were founded in 1988 as extended workbench for the industry, and thus we are one of the most experienced service providers in the field. We are a private sector service provider supported by an association of nearly 300 companies. We have 8 technology departments. One is the testing and analysis technology, where we have the material and failure analysis. We also do automotive testing for all main OEMs. We have a department for mold and coating technology, coating of molds in this case. We have several application engineers who are optimizing processes at our customers worldwide. Then there's a department for strategic market development, where the proficiency tests are organized also worldwide. We have another department for surface technology for molded part in this case. We have the possibility to electroplate, to paint, to print, and also use PVD at the Kunststoffinstitut. Another department is material engineering and development of new materials, and we have education, many educations and trainings in Lüdenscheid, but also at our customers, and we have a few products. I will come later to these products. Let's start with the first example. First example are round blanks made of PMMA. They are made as semi-finished parts, and the final parts for dental applications, were milled out of these round blanks. Our customer produces them by injection molding. Sample 1 is the sample from our customer, and he had big problems in the milling process. He had problems with chip formation at the drill. These problems did not appear at sample 2. Sample 2 is a sample from another company, and he came to us and asked us, we are quite sure that both material should be PMMA. Can you help us to find the root cause for the problems with our samples, and why does the other one work? So we started with one analysis, but we used more than one. First method is the infrared spectroscopy. The principle of this method is to stimulate molecular vibrations by light with a specific wavelength, and this leads to a spectral fingerprint of the material. This is a very easy method. You have ATR crystal, and you just have to put a very small sample on it, fix it with a stamp, and then you can measure, and the measurement will only take few minutes. Let's have a look on the results. Sample 1, remember, is the NOK sample. Sample 2 is the OK sample, and what we can see here is that the spectra of both samples are almost equal and show a very good accordance with the database reference of PMMA. So what we know by this analysis is that both round blanks are manufactured of PMMA and that we don't see any differences in the polymer material. So it's interesting, but it didn't give us the root cause. That's why we used a second technique. In this case, we use the DSC analysis. This is the most common method to determine the glass transition and melting points. We can also have a look at crystallization processes, decompositions, or vaporizations. The analysis is based on a controlled heating of a small sample. Only a few milligrams are enough. The required heat flow to keep the chosen heat flow rate constant is measured in comparison to a reference sample. This reference is not the OK sample, but it is an empty crucible. So have a look at the results. With DSC, we are normally working with 2 heating runs. You can see the first heating run of sample 1, of sample 2. Then you can see the cooling run, and we perform the second heating run. The first heating run gives us information about the material and about the process. And the second heating run gives us only information about the material, not about the process, since we have some irreversible effects in the production process. And if we heat the sample up, these effects are, let's say, deleted. We see in the second heating run, we start with that, slightly differences in the glass transition. 2 degrees is not so big that you can clearly say, there are big differences, but you can see you have just this one this glass transition, and this is within the typical range of PMMA. So this analysis gives us the information that it is an unmixed PMMA too. So, but we see big differences in the first heating run. We see a difference of 15 degrees in the glass transition, and we see an endothermal reaction. This reaction is very untypical for PMMA. And we see it appears only in the first heating run. So it has to be assigned to an irreversible effect. So this gives us information that there have to be differences in the production process. Not so big differences in the material, but very big differences in the production process, because we see differences in the first heating run, but not in the second heating run. So that helps us more to find the root cause, but it's not the final root cause that we see. So we performed a third method. In this case, we used the size exclusion chromatography. For the size exclusion chromatography, the samples are solved and injected on a column. The column is filled with a porous material and leads to a separation of the single polymer molecules by size. The bigger parts elevate earlier because they just go around the filler material, the column material, and the smaller parts have to go through the whole labyrinth. The result of this analysis is a molecular weight distribution that you can see on this sheet. You have sample 1 on the left side, that is an NOK sample, and you see that sample 2, the OK sample, has more than one maximum, and much higher average molecular mass. You have to notice this x-axis is logarithmic. This means you have a really high average molecular mass for the OK sample, which is higher than something that you can use in an injection mold process. The conclusion of this is, of all three analyses, is that the material is a PMMA, an unmixed PMMA, but we have this distinct higher molecular mass distribution. So that's why we can assume that the OK sample was not produced by injection molding, but it was produced by casting. So we have on the one hand a cast PMMA and on the other hand injection mold PMMA. This higher molecular mass leads also to different mechanical properties and thus to a different behavior in the milling process, and so this is the root cause for the lesser chip formation in this process.
Okay, if I jump in here,
yeah,
as you did last time, so if you have questions to these analyses, you could just ask them right away, and I would just pose this to Martin Dodd. If you want to ask questions, just please use the chat function on the toolbar, and you can type in your question. I will see it and then ask him. I have a question myself. You see on the first slide that these two, where you show the samples, you see that these are actually looking different. The one is blurred and the other one not. Is this a cause of the molar mass, or?
No, the cause is the surface of the mold. Here on the left side you have a blank mold, and on the right side you don't have a blank mold.
So you can really see
just the surface effect.
Okay.
If you polish it, it will also be look like this one. But only here you can see an injection point, not in this case.
So it's not crystallinity or something that is apparently different. Otherwise, you would essentially see it in a DEC curve. You would see some kind of recrystallization or so. Okay, which we don't see. So obviously here, it's well, you pick the right polymer for the right process, and obviously what they learned is if they want to produce like the competitors producing, you should use a casting polymer in a casting process. Is that?
Exactly.
Okay, so it's clearly so materials are somewhat different. Okay, I get some more questions.
Okay.
Could it not have been done by compression molding?
Yes, it's also thinkable, but yeah, cannot be excluded. But you need a process where you don't have problems with very high viscosity. It's not uncommon to produce such round blanks by cast process, so we assume a cast process is most likely, but compression is also thinkable.
Okay, another question. Is the high molecular weight distribution a consequence of the processing or from the raw material itself?
Somehow both. In a cast process, you have a liquid polymer, put it into the mold, and the polymerization appears only in the mold. So it's both the raw material and the process. And this peak is probably a post-condensation, a post-polymerization of the material. You can assume it, but it's not 100% sure. But that might be the reason for this peak.
I have this question as well. So it's as the person asks, what is the exotherm? It's actually not exotherm, but it's endotherm. Yeah. we see endo is up. So the glass transition
in Germany
is upwards.
it's quite common to use endo up. I know in USA it's more common to use endo up.
But it's an endothermal peak. However, it's actually in polycondensation. It's kind of a mixture between an exo condensation reaction and the endo evaporation of the water that is building. So it's kind of, well, it's a peak. So obviously something happened to this cast polymer. So that kind of explains the peak. But it's not, you didn't dig in the root cause of these peak, but you could clearly see that the difference in the production, what the customer is interested in, or in the failure, comes from the molecular weight distribution. Okay, questions are rushing in now. I'm just mentioning that if I'm missing one of your questions, don't worry. So there's we have more than 120 listeners now. We have the question assigned to your login as well, so we will get down to your question and answer this question later on then. Okay, formation of the chips related to the density. Since injection molding will probably get a higher density. So
yes,
can you?
Yeah, also thinkable, but yeah, it was not part of. We didn't do some milling tests at the Kunststoffinstitut. We only got the information and we didn't measure the density. But you're right. I think the density will be different, and that is also might also be part of the problem. But density differences appear due to the different polymer production.
Exactly. The root cause is the molecular weight of both.
Yeah.
And as it's been asked again, will these slides be available for download? You will have access to the webcast as we are over with that webinar, and you will be sent this webcast. So don't worry, you will get these slides to show to your colleagues and to your boss, maybe. Okay. I think we can continue with also for the time being continue with the next example that you have, Martin, with some different
different examples.
method.
Yeah. Second example is PVC lamellas for cooling towers are in this case not produced by injection molding, but produced in an extrusion process. But you might have similar effects in case of an injection molded parts. These lamellas are produced for many years, and the maximum heat load in the cooling towers was until now 45 degrees, and now there was a new cooling tower produced with a heat load of 50 degrees. Everyone thought, well, 5 degrees should not make a big difference. 50 degrees is below the typical glass transition of a hard PVC, which is about 80 degrees. So nobody thought that this might be a problem. But it was a problem. It was seen that these lamellas show a drastic deformation after a few weeks in use. So our customer came to us and asked us, is it really possible that these 5 degrees might be the problem? And that's why we used the method thermal mechanical analysis, TMA. This is a measurement of length changes depending on the temperature. That means we can characterize dimensional changes like shrinkage, like the coefficient of linear expansion, and we can also measure the glass transition. Important for this case is that you can prepare the samples directly out of the parts, and you only need very small samples. Only a few square millimeters are enough. Normally, we measure in at least 2 spatial dimensions because we want to analyze shrinkage. Shrinkage appears due to orientation of the single molecules, as you can see over here. And if you give heat to an orientated material, you will have shrinkage in one direction and maybe an increase of size in the perpendicular direction. This is why we normally use at least 2 dimensions to compare this. You can also measure films and fibers by TMA, then you won't use this standard sample holder, but there are many other sample holders to measure such things. Okay, let's directly jump to the results. You have on the left hand, you have the measurement in direction of extrusion. On the top, the red one is a completely new sample. The blue one is a sample which already shows this deformation. And in this case, we have two heating runs: first heating run, cooling run, second heating run. And on this side, you have a second measurement of perpendicular direction to the direction of extrusion. What do we see here? We see in the first heating run of the new sample a drastic contraction of the material. We have a shrinkage of more than 9%. And we don't see this shrinkage in the already used sample. That gives us the information that this shrinkage already appeared in case of this sample, because it's an irreversible effect. So if it happened once, it would not happen again. That's what you can see in the second heating run. You don't see any shrinkage. And in the perpendicular direction, you see an increase of the size by 2%. And if you see 9% shrinkage in the one direction, 2% increase in the other direction, that gives you a clear information that that you will have drastic deformations of the parts. So let's have a look on the 50 degrees. We started evaluation a bit higher than 50 degrees, but you can already see a very slightly decrease of the curve at 50 degrees. You have to notice this measurement is quite fast. We are heating up with 3 kelvins per minute. So this effect will also appear if you hold the sample very long at a lower temperature. You don't have to heat it up to 80 or 90 degrees, as in this case. It will also appear if you heat it just to 50 degrees up. As you can see, the deformed sample did not show the shrinkage, so we can be sure that it already appeared. Our customer asked us, okay, you have given us the root cause. We have a problem with shrinkage. We have bad process parameters, but is it really 5 degrees? Does that really matter? That's why we performed a second measurement, again with a new part. We tested a new part at 45 degrees for 4 hours and keep the temperature constant, other than here. Here we have a dynamic temperature, and here we kept it constant, and what we see is a very small contraction of less than 1%. So this gives us the information, yes, these 5 degrees do matter. So the conclusion is that there have always been bad process parameters, but these bad parameters are only critical at 50 degrees, not at 45 degrees. We do not only analyze such problems, but we also try to help our customers to solve them. That's why we recommend, in this case, optimization of the production process. For extrusion, it would be a lower of the haul-off speed. If we have injection molding, you can optimize the temperatures and the speed of injection. And of course, periodic TMA measurements are recommended.
Of course, yeah, thank you, Martin. Of course, at NETZSCH Analyzing and Testing, we like the last sentence very much. Periodic TMA measurements are recommended. However, you obviously see it's a small effect for a big effect in the end that obviously makes this part fail. I have a question already that was asked. Annealing this material prior to use, would that be a solution? Would you recommend to anneal that?
It might be a solution, but in this case, you will have the annealing will lead to a contraction before assembling it. So but if you have such a such a strong contraction, you will have problems with deformation after the annealing process. And
you would just
in this case, I don't think that it's possible to that annealing is enough. If we only have 1 or 2% annealing, would be a good idea.
Yeah, I think so. So actually, annealing would only produce the failure right away, let's say.
Yeah.
However, it wouldn't go around the root cause. But annealing is commonly
annealing helps. If you only have a small effect, it's okay that this effect appears before you assemble the parts.
That's more, I would say, if you have. I see that sometimes for thermosetting polymers, if you, let's say you have still have post-curing or something like that, then parts are very oftenly annealed. But of course, if this annealing will only produce contraction or shrinkage or dimensional change, of course, this will alter the entire appearance of your part. So you should understand the production process better. I have another question. How do you clamp a fiber on the TMA stage?
Yes, maybe you can answer it.
Oh yeah, that's just the sample holder for expansion. However, of course, obviously we could do a whole webinar about sample fixtures for the TMA, I guess. What you would do is you have you put a clamp on the top and on the bottom of the fiber, and you hang it into a holder, and then you just put a small force on it to keep it stretched, and you watch the elongation as you heat it up. So that's just straightforward, and it's just another sample holder of the TMA. I think you frequently use this sample holder as well, Martin.
Yeah.
Yeah. Okay. One more. I have a question to the one before. So maybe I would. We come back to the questions about the first sample later on. So for now, I would say, as we're a little bit advanced in time, as we took some time for answering the questions, but still we should have shown your last sample.
Okay.
Doing again another method and looking at a different failure.
Yeah. In this case, we analyzed polypropylene recycling material, and we had problems with the mechanical properties from parts from the current production process. Moreover, we had our customer had problems with brownish streaks on the parts, and earlier production process batches do not show these problems. In this case, we used the DSC again, in this time in combination with the identify option of the NETZSCH Proto software. First, we measured part sample cuts it out of a part from an OK sample, and what we can see that we just have a single peak with a maximum at 167 degrees, which is in the typical range of a PP. That's what you would expect if you measure unmixed PP. So we also, of course, also measured an NOK sample, and as you can see, we don't only have the PP peak, we have also a second peak at 132 degrees, which is distinct pronounced. It is not only a very small peak. That gives us the information that well, it's not really a quantification of it, but it's more than just 1 or 2% of this material. And moreover, we got a glass transition at minus 54 degrees or 55 degrees. And yes, in this case, we see, okay, your problem is that you have a material mixture with something else. And our customer asked us, okay, that's interesting, that gives us an idea why we have problems, but what is the mixed material? For this, we used the identify option of Proteus, and we just picked this peak. This was the interesting one for our customer, and we did an automatic database matching. As you can see, we have a very good accordance, a similarity with high density polyethylene. Hence, we know not just it is mixed, but it is mixed with HDPE. The glass transition is a bit harder to identify. It's possible that it is a TPE or it is EPDM. But this peak is very clear. So in summary, we have detected impurities in the current material batch, and we also identified it as a PE by database matching. This mixture will lead to lower mechanical properties and might also lead to the brownish streaks, since if you process PE with PP typical process parameters, this might cause a degradation of the material and hence these brownish streaks. In this case, we used, as I said, identify from NETZSCH in combination with a database that the Kunststoffinstitut invented in this year and the last year. This database contains 600 different databases, and this helps to identify unknown polymers, unknown mixtures. It's really helpful for us, and also might also be helpful for you. It's available at NETZSCH. Okay. As I said, we use different techniques. You can see over here the DSC polymer, the DSC analyzes from NETZSCH with the auto sampler, so that you can measure many samples all day and all night. And the TMA, for TMA, auto samplers are not possible, but this is also a very, very good and important method if you have do failure analysis, especially for shrinkage and deformation problems. Last but not least, I will invite you for our Plastic Analytics Congress in November at the Kunststoffinstitut in Lüdenscheid. We have about 25 manufacturers of different testing devices, many presentations. One of Mr. Flock, and we also
I'll
have
be there.
you will be there, and we also have a hands-on session. So it is possible to bring your own samples with you, and we will try to measure them. Okay, that's it from my side. Thank you for your attention, and I think we go back to questions and answers.
Yeah, that's right. So I come in again, and I think we stay with your presentation for a little bit, Martin. We still take some time. So we will be here, let's say, until the full hour. Let's say, as we generally did, depending on how many questions you have right now. For the beginning, I have a question already. Before I go back to the other ones. So, with regard to failure analysis, I mean, we saw some really different causes. So the first one was a material question. The second with the PVC, if I think back, was due to processing, and the third one was again a material thing. But I would have all these different parts. Is there any general recommendations from you how to prepare the sample from you? Or from this?
Prepare, or
I mean, it depends on the method.
Depends on the method. We are often working with a side cutter, with a scalpel, but we use many different things. We also use a bandsaw. I don't know what flex is in in English, but
yeah, yeah, that's a good. If you have really tough samples, like metal samples, sample.
Very different things.
You grind it off. Okay. You said, but of course, it's probably recommended if you have a failure, let's say a part breaking or so.
We try to take the sample in the area of the failure, and it's important if you prepare and you have like a bandsaw or another saw, you have heat. You have to cut the edges of the sawing away and don't analyze them.
Yeah, so it's matter. The more gentle you do your sample preparation, the better it would obviously be for your analysis, because you don't want to change the sample by preparation, but by
most mistakes are made in the sample preparation.
Okay, yeah.
Analysis.
Yeah. I know that from my own experience. But let's go back to the questions that you posed. I had a question with respect to the first example. That I know that obviously people are really looking into this into detail, so I would just ask you, how do you conclude that the molecular mass is dominating and not material density? I think this is also the right graph to answer exactly this question.
I'm not really sure about that, but in case of a high molecular weight, you will have a very long single chains, and this will lead to a very different behavior. It's not possible that one chain can slide easily, or it's harder possible that one chain can slide easily along another chain, so that will definitely make a big problem. Density is also possible, but I don't think that
is lower, I guess. So from my perspective, with respect to density changes, so changing a density of the polymer, it's actually quite hard. I mean, you change you can change it a little bit by different processing. However, if you look at this graph and you look at, so the molecular weight differs by 1 order of magnitude. So this is not just a few more monomers, but it's 1 order of magnitude more. So, I mean, of course, if you would do mechanical tests to this, which is kind of a, I mean, it's a destructive testing, the milling. If you do mechanical testing on this, this would also clearly show differences in the mechanical performance, would it?
Yeah, definitely.
So if you do like tensile tests and so on, this would clearly show a different performance. Is that, would you agree, Martin, on that?
Yeah, I agree.
Okay, another question, that would be one for me. Identified database. How does the identified database work with the Proteus software? So that's just a maybe configuration thing. So I say all the latest softwares, including the one for DSC Polymer, they include the identify algorithms. So you can make your own database. You can set up okay, not okay databases, or you can set an okay database and you will find not okay samples really easily. However, the database that Martin was referring to is a commercially available database of 600 DSC curves, and it's not any DSC curves. They were all done in the same way, and we can clearly say, from an accredited lab. So you put a lot of work into this, I know.
Yeah.
It's more than just one measurement of a sample, as I knew. And this is a separately available database that you would just get from, if you contact local sales, or you can contact me later, and we can get your quote on this. This is part of the co-work of Kunststoffinstitut and Natural Analyzing and Testing, in person of Martin and myself behind this database. Okay, I have a question. SEC, size exclusion chromatography. Can you please explain how to interpret the graph and to analyze the molecular weight?
Yes, you have
molare Masse is German for molecular weight.
Yeah, it is. And so you always have a distribution of the molecular weight, and yeah, that's what you can see here. And this is only the intensity of how this gives you an information how many of these molecules were detected at this molecular, this single molecular mass. And yeah, you have a maximum, but you often use not just only the maximum, but you work with the weight average of the molecular weights. It's a bit more complicated to explain it in just 5 minutes or 2 minutes. So if you want to know more about it, maybe we can talk about afterwards, or I can use some more sheets about this. Show you some.
Okay, that's kind of that paves the way for a new webinar. Although, but I mean, as I know that there's you have so many different methods. I guess about 10 or 20 methods in your lab. But so this, of course, only gives
only in the analysis lab. In the whole institute, we have more than 50 or 70 different. Not more. No, if we also talk about the very small tests for scratching or something, we have more than 100 different methods. So
okay. But the listener, she's asking again that she's actually asking if you can quantify the molecular weight automatically through the instrument software.
Yeah,
we see the numbers only very they're.
Yeah, we are often working with a relative molecular mass. You do a calibration right before the measurement. In case of PMMA, you can really calibrate. You find many standards of PMMA, but sometimes you also use a PMMA standard for a measurement of, let's say, PBT. So in this case, you only get relative molecular masses, but for PMA, you often get the absolute masses. And
so we
for
see
the
here,
other,
yeah, this is molecular size of 10 to the power. So the red curve, the longer chains, they're 10 to the power of 6. Is that right? So 1 million monomers.
Yeah.
Yeah. Okay. I hope this answers the question. I see. Let me just check if there. There is a just a remark about mechanical properties with respect to molecular weight distribution. Higher molecular weight equals higher toughness. An example is polycarbonate, where a 24 melt low mole weight has a lower impact than 12 melt with a higher molecular weight.
Yeah.
I guess you could agree on that. Yeah, this is what I've been talking about. If you would do mechanical tests on this kind of sample, you would also really see it. Okay, one more question. That's also for me. Identify database can be installed in already. If you have Proteus already, can you get Identify as well? So there is a certain software after which it works, but you can certainly just update the software and get both the Identify functionality as well. So you could just this comes with a newer software version, and yeah, you can go back and you can additionally get this database with all these different curves. Actually, if you go back one slide, Martin, maybe. Yeah, you see that there's also the green ones. The green entries in the database, these are the ones that come pre-installed with the database already. So that just gives you a handle of, well, different polymer types. But that's just a rough overview. I don't know if some of you are familiar with our with the NETZSCH polymer poster. So all the ones that are on there would be in green, and the 600 ones from Martin Doth from Kunststoffinstitut Lüdenscheid, they would appear in red. But there's a lot more information on these. You have, what do we have? We have filler contents. We have commercial names.
We have color. We have
colors. Supplier. So it would really be, you would really be able to trace down a polymer type, and you would be able to know the bag of polymer that you have to buy in order to get the results. Okay, still another question about size exclusion. Size exclusion, isn't the SEC graph also showing? We go back. Yeah, here we are.
Yeah.
Isn't the SEC graph also showing a higher fraction of lower molecular weight, which could also negatively impact mechanical properties?
I think you might
refer.
Are you talking about the OK or NOK sample?
Maybe it's not.
Yes.
You see the long tail here.
Yeah, you can see a long tail. That's also a hint for
and you see the double peak here. Yeah.
Yeah, and here's a third peak. So yes, this can be a hint that the production process is a casting process, since you have the polymerization during the process. So it's less controlled. The molecular weight, the average weight, is less pronounced, clearly, in comparison to a wider distribution due to the production or the polymerization of the material in comparison with an injection molding material. And of course, this will have an influence on the mechanical properties too. So that's why it's not possible to say this one will exactly have this tensile strength or something like that. So you have to perform mechanical properties if you will want to know how big these differences really are.
Okay, so I mean, you can always do more analytics, I guess, Martin.
Yeah.
Is that right?
Yeah.
However, I just take this as a general recommendation. Of course, obviously, if you get a failure, it might be too late. But of course, there's ways to learn how to operate a DSC. So at some or the other point, it might be interesting for if you do incoming goods inspection, or as Martin recommended, maybe once or twice. It's very helpful to do TMA measurements. You just click into the end, I think. So okay, yeah. So that's a general recommendation. Of course, we at NETZSCH have ways, and Kunststoffinstitut is a very good reference for. It's a very good reference
for service provider labs.
Yeah, exactly. To learn more about these methods.
Okay.
As I said, we just approached the full hour, so I would say we're about to at the end of this webinar. I just switch quickly over to my screen again, and just well, in the name of NETZSCH Analyzing and Testing, I thank you very much for joining us today. Yeah, Martin, you want to say a few words?
Yeah, thank you for your attention and the very interesting questions. Yeah, if you have problems, if you have failures, of course you can contact us and we will try to help you.
You will also find us on LinkedIn. Both Martin and I are on LinkedIn, or you can follow the NETZSCH channel for the latest announcements on different methods. So we really try to bring new things in there. Well, it was nice having you, Martin, here. Very well done.
Thank you for the possibility to speak.
Yeah, thank you for this really interesting and well, all these applied problems that really show how things sometimes go. Of course, you did not go too much into the arguments with the customers that who did what wrong in the process. But I think in order to improve failures, we really have to skip this and look at the root cause. And I think this failure analysis would just be one step in the right direction. So thanks for joining us this morning or this afternoon. Please stay with us in the name of NETZSCH Analyzing and Testing. Thank you very, very much. We just stay in touch, and I wish you a nice day. Bye-bye. Thank you.